In today's video, here is a nice problem regarding arithmetic and number theory. Here is the following setup. For all n as a natural number, here is the following statement. We have n squared minus 2n plus 8 is a perfect cube. Okay, so our goal, we are going to solve this equation in order to determine n to make the whole thing as a perfect cube. Okay, so let's take a look to see how to deal with this one. Okay, so here is the following equation. We are saying this expression as a perfect cube. It will be written on this form. So now here is a thing here. So the first idea is coming to our mind. We are going to factor out this quadratic. Okay, so n, I get n factor n minus 2. I'm going to take 8 to the right side. So we know 8 is the same as 2 cubed here. So I'm simply going to factor out this difference. I get x minus 2 factor x squared plus 2x plus number 4. Okay, here is a kind of relationship between this left hand side of this equation and the right hand side of this equation. Since n divides the left hand side of this equation, which means n divides the right hand side of this equation as well. Okay, so but the problem, we don't know n which one is going to divide, this one or this one. So we are going to force this one. It's impossible to be divisible by n. Okay, so by the way of contradiction, suppose n divides x minus 2. Okay, this one is telling us n must be inferior or equal to x minus 2. So the next thing up that we are going to use here, so we know n cubed always is strictly superior than n squared as an n natural number. Okay, also this n squared must be bigger than this expression n squared minus 2n plus 8. But which condition? The condition when we have n is superior or equal to 5. We know this expression equals to x cubed. Okay, for all n is superior or equal to 5. For all n superior or equal to 5. So we know n cubed is strictly superior than x squared. So when it's telling us n is strictly superior than x, since we have this expression here, we get x is strictly inferior than n is inferior or equal to x minus 2. So when it's telling us x is strictly inferior than x minus 2, which is impossible. Okay, n must divide x squared plus 2x plus number 4 because of this contradiction, because we forced this one to be out of this possibility, because we forced this one and cannot divide x minus 2, which means n divides this expression. But on this condition, what about you might say, what about if n is inferior to 5? So you guys are going to check that. You will find it's impossible n can divide this one. Okay, I'm not going to do that because I want to save the time. So you guys, I'm going to leave you to do it. Okay, when we have n belongs to this one, so which means for all n from this interval 1, 2, 3 and 4, also n not divides x minus 2. Okay, you guys are going to check this one. Then finally you get n must be divided this one. Okay, now this is our start. We are going to start from these essential points. Okay, so according to the divisibility statement, n divides this term, which means x squared plus 2x plus number 4 equals k is multiplied by n. Okay, where is a k is a sum of natural numbers. I'm not going far away from this one. I'm going to take this expression and throw it here. Okay, so I get n factor n minus 2 equals x minus 2 is multiplied by kn. Then I will have n cancelled out, since we have n is strictly superior than 0 because it's a natural number. Okay, now I'm going to simplify this one more. I get n equals x minus 2 factor k plus number 2 after taking minus 2 to the right. Okay, then I have this nice expression here. I'm going to take this expression and plug it into this one here. Okay, so I get here the following. I get x squared plus 2x plus number 4 equals x minus 2 k squared, because I'm plugging just n with this one to have k is multiplied by this expression. Okay, plus 2k like this. Now I'm going to fix k and make x as a variable, okay, in order to solve this quadratic equation. So by taking all the objects to the left to one side, so I get the following equation. I get x squared, and we'll have plus 2 minus k squared is multiplied by x plus number 4 minus this one plus 2k squared minus 2k. Okay, the whole thing equals to 0. Okay, now we have end with this final expression. Now I'm simply going to calculate the discriminant of this one, which is delta. So I get delta here equals this term quantity square, which is 2 minus k squared, the whole thing is squared, minus 4 times is multiplied by this quantity here. I get 4 plus 2k squared minus 2k. Okay, let's take this expression on the top and continue solving our equation. Now let's transfer this one into inequality. Okay, so we know if I'm going to transfer this one into the perfect square as a quantity square, I get k squared here minus 6 all is raised to the power number 2. Okay, so distributing this one is given as first term and middle term, they are okay, but we need the last term. Last term we have 36. We don't have the 36 here, which means we are going to put minus 36, which means 8k. I'm going to bring this 8k down here. I get here minus 36 minus 12, which is minus 48. Okay, now let's transfer this one into inequality. I'm going to this term, which is k squared minus 6 quantity square, must be strictly inferior than this term, as well as also this term must be strictly inferior than this term, minus 5 quantity square, like this. Okay, so how this one can be true? This one is clearly true, but we are going to check this one. So it's more confusing here since we get the 8k here. So let's distribute this one first. If I'm going to prove the difference of this one and this one is strictly inferior than 0, which means the inequality holds the left hand side of the equation, which means that this inequality holds. Okay, so I get here k to the 4th minus 12k squared plus 36 minus this difference, which is this one, minus k to the 4th plus 12k squared minus 8k plus 12. Okay, so I get a lot of stuff will be cancelled out, this one and this one, this one and this one. So I get here 36, I get here 36 plus 12, which is 48. 48 minus 8k. Let's take 8 as a common factor here. So I get here 6 minus k. Okay, so which condition to make this inequality strictly inferior than 0? This one, if k is superior or equal to 7. Okay, because if k equals 7 here, this one become negative. Okay, that's what I want. So this inequality is holds if only if k is superior or equal to 7. Okay, for the right hand side of this inequality, it's clearly this one, it's inferior to this one, which means we have proven a perfect square, which is delta, is between two consecutive squares for for all keys super equal to 7, this is impossible to be true because you cannot find a perfect square between two consecutive squares. Okay, so which means key it cannot be super equal to 7 since we found this contradiction, which means key must be strictly inferior than 7. Okay, in the other word, key must be in this set 1 2 3 4 5 6. Okay, now let's get rid of this one and move on to the next step. Case number 1, if key equals 1. If key equals 1, I'm simply going to replace key here. So I get n equals x minus 2 plus number 2. So I get number 2 cancelled out. So I find n equals x. Let's take n equals x and replace them into this equation. Okay, so we get n squared minus 2n plus number 8 equals n cubed because I have replaced x with n. Okay, so the next thing up, let's take n as a common factor here. So I get n factor n squared minus n plus number 2 equals 8. Let's use a small trick here. So I get n factor n minus 1 plus number 2 equals 8. So we know this term is an even. This one is an even. Okay, which means the whole thing is an even. Okay, so which means n, it could be odd, it could be even. If this odd equals 1, okay, if it's even, is going to take number 2 because this term is bigger than this term, which means n is going to take small terms. Okay, so if n is an odd, which means n is going to take number 1. If n is an even, n is going to take number 2. Why? Because this term is smaller than this term. Okay, because we have a product here. So let's take if n equals 1, is not going to work here, because if you replace n with number 1 here, you get 0. You get number 2 here. You get 2 equals 8. 2 equals 8, which is impossible. So this case will be rolled out of this possibility. So I'm going to take only n equals 2, which is works here. Okay, so if n equals 2 and take n and replace it into this equation, you get 4 minus 4, which is 0. 8 will be written on the form 8 is the same as 2 cubed, which means I have one solution here. So I get n equals 2 with x equals 2 as a first solution. Okay, you know what happened to all other cases? We are going to do the same job that I have done here. So we will find this one doesn't work, this one doesn't work, this one doesn't work, this one doesn't work, this one doesn't work. You guys, you can check that. I'm not going to do that because the video will be longer than usual if I'm going to do that. Then if you check all of those values here of k, none of those values can give us a solution. Okay, which means the only solution that we are going to find this one. Okay, so I have done with this problem. If you have any question regarding this problem, just put it in the comment section below. If you have any suggested problem, you can put it in the comment section as well. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.